Okay, we're going to go through the second part of chapter 2, which is how we display quantitative data. So the first little video that was relatively short was about categorical data because our displays are very limited. But for quantitative data, we have more options. Remember, quantitative data are numeric values that also have measurement units. So these are measurement scales. And right now, we're pretty much referring to displaying one variable at a time. So this is one at a time. Okay, so it's a single variable displayed, and we have several different representations of that we can make. And we're going to talk about and kind of go over a couple of these in class together. The first is a histogram. We're going to make a histogram, and we're going to make the second one together. So a histogram is where I organize, I don't know if you guys can see when my screen I accidentally enlarge it on myself here. Make a mistake if that happens. So this organizes the data into ranges, okay, or bins. So what we do is we kind of chunk our data out. So in class, we have data that's in test scores. So all of us have been students before, and we know that test scores are very typically arranged in bins that are about 10 units wide. So that's probably what we're going to do when we do an example together in class. But it organizes the data into ranges or bins, and each bin is filled with a bar. I know this sounds like a bar graph, but there's a very particular difference, okay? So it organizes data into ranges or bins where each bin is filled with a bar whose height represents the frequency in that bin. And I know that this sounds really kind of crazy, and definitions are hard without examples, so bear with me. We will do an example of a histogram in class with some test scores data that I have in the student packet. Okay, if you want to, you can even pull up my solutions right now and take a look at what a histogram looks like, or go ahead and take a look at some of the videos below from YouTube that our coordinator posted. Okay, so other picture that we take a look at would be the stem and leaf display. So this is like a histogram, except the stem, I should spell the word, the stem is, represents, let's say, the tens digit, and the leaf represents the singles digit of a number. So for instance, a stem and leaf plot might look like this. Okay, where you would read this as 1, 2, 12, 13. So again, that'd be 1, 2, 12, and 13. That's what is in this little stem and leaf display right here in this example. Okay, and then the other kind of display we might look at in your online homework is a relative frequency histogram. But we very rarely take a look at those in class. So we're going to just move on and talk about how you would describe one of these pictures. So all of these quantitative data displays can be described in the same way. So there are 3 questions to ask about, let's call it the shape of your picture. Okay, the first is how many peaks does it have? So this would be like bumps. So how many peaks does the picture have? If it has one peak, it would be referred to as unimodal. Okay? But let's say the graph goes up and then down and then up and then back down again, which is kind of like a roller coaster, right? That sounds like two peaks, right? That would be considered bimodal, all right? And then the second, let's say greater than 2, let's just make it, right? Greater than 2, so 3 or more, we would consider to be multimodal. And then the only one that would be like a picture that has no peaks would be a flat picture. We would refer to that as uniform because all the peaks have the same uniform height. Kind of like people wear uniforms so that they all look the same. Okay? So these right there are our ways to describe the picture. And that would be like in terms of its modality. All right? Okay, question number 2. Is the picture symmetric? Okay, so here's the deal. We either say it is symmetric, right? Or we say it's not, but we actually define this, right? So we would say it's skewed. Left or right, right? We'd have to define which direction this picture is skewed. So symmetric, right, would look like, let's say we lie a blanket over the picture, okay? So symmetric, if this were a histogram with a bunch of little bins in it, symmetric would look something that's pretty terrible, but something like this. Okay. Skewed left is what we're going to do first. Skewed left is weird. You'd want almost the data to be on the left, but what that means is that there's a long skinny tail on the left and the data is actually on the right. So this is skewed left. And this would be a picture, exaggerated picture of something that's skewed right. I'm going to, like this, right? So skewed right. And when we do an example of the histogram in class, I am literally going to imagine a blanket being laid over this histogram to try to help us understand what's going on with the shape of it, okay? Okay. I'm going to go to my next slide, but don't worry, you can always pause the video or come back to this at any point, all right? So we're going to go on to question number 3. Our third question, oops, excuse me. I want to go on to question number 3. Hello. Okay, question number 3, which now that I got messed up on my slides, I keep getting distracted. Oh, are there any unusual features? So are there any unusual features? So what do we mean by this? So the first thing that we mean would be like a gap, would be a bin with no data inside. So that is a very unusual feature in a histogram, and we will see if we have those in the pictures that we look at together. The other unusual feature that we tend to look at are what we refer to as potential outliers. So these are values very far away from the rest of the data. Okay, and we only refer to them as potential outliers because in chapter 4, I believe, we learn of a way to mathematically define them as outliers. So we don't want to call them actual outliers until we do the math. But right now we can refer to them as potential for sure if we see a value that just seems like way far away from the rest of the picture. So let's see. I'm going to put gaps and a potential outlier. So this is a fake me out histogram, okay? And then over here are some gaps, right? So this would be a gap. Right here is another gap. And then these right here would be what I might refer to as potential outliers in this particular histogram, okay? So we've got literal gaps in our bins where there's no data at all, and we've got these two values that are really far away from the rest of the data, so we would consider those to be potential outliers. Okay, so we're going to move on to the next concept that's going to be discussed in this particular chapter, and that is the appropriate measure of center and spread, okay? So center and spread. So I'm really going to give a very general kind of explanation of what's going on here. To me, I almost want to start with the picture of the data because when we look at the picture in the future, we want the picture to help us determine our center. So if we look at our data, and let's say it looks like this first picture that I drew back on the previous slide, which if you guys remember is symmetric. But the other thing that it also is, it only has one peak, right? So it's also considered, using my language from the first slide, unimodal, okay? So if I can describe the picture this particular way, then I have a very specific center and spread that I want to use to discuss it. So the center for this picture would be its mean, and I know you know that word, right? The mean is also considered to be the average, and in our class, it's denoted with the symbol X with a line over it, which I will say as X bar, okay? And honestly, guys, it lies smack dab in the middle of this picture. And then the spread is a number that's supposed to help us talk about where the rest of the data is. So without going too far into it, because I will go further into it in chapter 5 when we discuss this further, the spread here is called the, and I know this sounds familiar to some people, standard deviation, which is literally telling me whether the score, or sorry, how far the scores deviate or are away from the middle of the data. So if we have unimodal and symmetric data, then we would describe it using the mean and the standard deviation. But, and now I'm going to put a big divide down the middle here, okay? Still talking about center and spread. But now all of a sudden, I'm either staring at a picture that's skewed left or skewed right, right? So I've got skewed, and I'm just going to put a big L for left, and this one is skewed to the right, all right? So if I have either one of these pictures, or I'm looking at something that's symmetric but it's not unimodal, right? Something that just doesn't fit symmetric and unimodal. If I'm looking at something that's skewed, then I would never want to choose the average as the middle, okay? So I want to be clear, and I'm going to be being clear involves, in my opinion, using extra colors. So we're going to go ahead and use orange for the mean. So right here is, well, that's not a great color, but right, it's like peach. But right there is my mean, X bar, in that picture, right? So I want you to look at the picture that's skewed left, no longer the one that's unimodal and symmetric. If I'm staring at data that's skewed to the left, then that means that on the left-hand side, there are some extremely low scores. Well, if that's the case, then somewhere over here, where those low scores are, is my average. All right, it is pulled in the direction of the skew. So again, I'm going to go ahead and put my average over here on the right when my picture is skewed to the right, because the mean is affected by any skew. All right, so it's very important when we look at this picture on the left that we ensure it's unimodal and symmetric if we declare the mean to be the center. Because if we're looking at the pictures on the right-hand side, let me switch colors here, the center kind of appears to be like where the data is. Wouldn't you call this more like the center kind of where these pictures really are? Okay? And these particular centers are, in fact, the same value. Depending on whether it's skewed left or skewed right, the center moves based on the skew, all right? So this center is referred to as the, and I'm going to write it in that color. Oops. Let's write center. Right? Center here, and then we're also going to write spread on this side. Okay, so this is going to take a little bit more explaining because we haven't gone over exactly what these words mean, but some of you have heard this first word before. All right, back to the color that we use to draw this picture. The center here is the median. All right, and this literally splits the data in half. And I mean 50% of my data lies on the left of the median and 50% of my data lies on the right of the median. And then the spread here would be referred to, and I'm going to use its abbreviation first. We call it the IQR, and then I'm going to write it out over here. Interquartile range. Okay? And the IQR here is referred to as the interquartile range. Now, I'm going to go ahead to the next slide to try to explain a little bit about what the interquartile range represents, because we will need that information in the following chapters. So bear with me just a little bit longer and this video can finally end, all right? So one more explanation. We're going to talk about the IQR. What the heck is that? The interquartile range, okay? So this is actually the middle 50% of the data. Okay, that's supposed to be an exclamation point. An IQR is like literally a fancy way of saying it's the middle 50% of the data. So I'm going to draw you a picture kind of to show you what the values are in a data set, let's say. Okay, so let's say we have a minimum value and a maximum value, and we just like lay them out from start to finish. Well, smack in the middle, and I'm going to do my best, is the median. Okay, so remember, this picture is supposed to be representative of percentages of data, right? So there's 50% of the data on the left and 50% on the right. So what we discuss in terms of the spread that goes along with the median is actually chunking out the rest of these pieces. So somewhere between the minimum and the median is another middle. So this is considered Q1 or quartile 1. And then we have another one over here between the median and the max, which is considered Q3 or quartile 3. And so this picture might look kind of crazy to you, but what if I do this, right? This is now, quart means quarter is 25 cents, right? So maybe the word quartile will help us a little bit more if we can see that I just broke this up into chunks that are each a quarter or 25%. And then finally, the IQR is the difference between Q3 and Q1, which represents the middle 50% of the data. And you can see in my picture, it is literally representing the spread that goes around the median. Okay, so it's our job now to identify pictures and describe what they look like and try to make some on our own. So meet me in class and we will do that all together.